The Sullair single axle controller, also known as the mini compass. The Sullair single axle or mini compass controller was designed for controlling the compressor system operation and access to adjustment of the machine parameters. It utilizes digital technology for performing maintenance operations that ensures accurate and safe operation of the complete compressor system. When a fault condition occurs, the controller will automatically shut down the machine to prevent injury to the operator or damage to the equipment. Features of the mini compass controller include a service pressure gauge, automatic self-diagnostics at startup, multiple language support, and external diagnostic support, which allows PC interface for configuration of the system parameters, backlit master gauge to allow clear view in low light areas. These are the individual components of the instrument panel. Master gauge, LCD display panel, user interface buttons, engine shutdown lamp, diesel particulate filter lamp, DPF, high exhaust system temperature lamp, HEST lamp, regeneration inhibit lamp, diesel exhaust fluid lamp, low fuel lamp, engine warning lamp, compressor shutdown lamp, compressor warning lamp, e-stop switch, high-low valve, only on dual pressure capable machines, the start-run valve, engine controller diagnostic service port, i.e. data link, power on-off switch, i.e. ignition switch, the force inhibit regen switch. When the ignition switch is placed in the on position, the startup mode becomes active and the single axle controller turns on its switch power output. It also turns on backlighting and runs through a self-test, a communication test, and a fault condition check. The display will first go through a self-check and then display any warnings from the communication check. If no fault conditions are present, the single axle controller will broadcast a ready message on its display. Upon pressing the ignition switch to the on position, in unison, the gauge pointers will move to the 0 position, then to 50% and 100% of its scale, and then back to 0. The LCD display will turn on all of its segments for 1 second, off for 1 second, and then display the Sullair logo followed by the firmware product number with revision level. Finally, all warning lights will turn on for 5 seconds and then turn off, then set to the actual indicated state. The Message Display Center is a graphical backlit LCD that displays compressor operational information. The LCD is divided into two main portions. The upper half of the LCD is reserved for the first line display. The lower half of the LCD is reserved for the second line display. Both lines have distinct messaging characteristics. The first line display contains high priority system operational information, and the second line displays low priority messaging or operational parameter display. Settings and Diagnostics menu. While the single axle controller is in any mode, pressing the M button for more than 5 seconds brings up the Settings and Diagnostic menu screen. Navigate the menu items using the M or T buttons until the desired item is highlighted. Simultaneously press the M and the T buttons to select that desired item. 5 seconds of inactivity exits the menu. There are 8 items on this menu. Set units, set language, contrast, single axle controller diagnostics, pressure calibration. This should be done at every check-in procedure. Backlight adjustment, engine diagnostics, prep engine program, and engine shutdown history. Now we would like to demonstrate doing a pressure calibration. This is something that should be done every time the unit comes back from a rent, getting it ready for the next rent. Once pressure calibration is highlighted, press the M and T buttons at the same time to activate this selection. Use the M and T buttons to change the parameter to the desired setting. We are now on the calibration screen. To change your setting, you use the M or the T button. to change the number on your right. The goal is to get the number on the left to read 0 psi. Once you have the number on the left to read 0 psi, save your setting by activating both buttons at the same time. This takes you to the previous submenu where the transducers will be displayed again. To exit from there, you simply press both buttons again. By pressing both buttons at the same time, your setting change is then stored. The unit will reboot and go back to the ready state. The next menu we'd like to demonstrate is the configuration menu. To enter this menu, you hold the M and T button down simultaneously while turning the ignition switch on. This immediately takes you into the configuration menu. This brings up your line 2 parameter yes or no. Currently it's selected to yes. If this was selected to no, the line 2 parameter would not be visible during normal mini compass operation. To change this selection from yes or no to yes, you use the toggle button, the T button. Once the desired selection is highlighted, you simply activate your selection by pressing both buttons simultaneously. This reboots the controller back to the ready state. What we'll demonstrate now is the startup of the compressor. With the e-stop in the disengaged position, the start-run control valve in the start position, the mini compass controller in the ready state, the ignition switch can be pressed to the crank position for starting. The start-run valve in the start position is holding the inlet closed, basically putting this machine in a forced unloaded state. This keeps the sump pressures down to a minimum, just enough to have oil flow so that the engine can start freely and keep torsional vibration down. How long the warm-up control valve is in the start position is really ambient temperature related. The colder it is outside, the longer you should leave it in the start position. Once the engine's warm enough, you can transition the warm-up control knob to run position. This loads the machine and makes it ready for the end user or the operator. Now that we're warmed up and we're in the run mode, providing service air, let's go ahead and scroll through some of the parameters that are available to us on the line 2 parameter. To display line 2 parameter, simply press the M button for a couple seconds. The line 2 parameter will be highlighted. Let's go through the different ones. Engine coolant temperature, battery voltage, percentage of engine load, fuel rate, gallons per hour, fuel pressure, fuel temperature, engine air temperature, oil pressure, boost pressure, turbo, desired speed, percentage of soot level in the DPF, ambient air temperature, fuel level, engine speed actual, hours, service pressure, which is P1, and back to coolant temperature. What we would like to demonstrate is the 3 states a compressor will be running in: unloaded, modulated, and loaded. We will start off with unloaded. With the ball valve closed, what we're simulating here is the operator having all of his equipment turned off with no load being asked of the compressor. At this point, the compressor has reached its unload pressure settings. This will cause the engine idle to drop to minimum and the inlet valve to close. Now what we're going to do is we're going to start to open the discharge valve. We're not going to open it quite all the way or even up to the point where the machine will be fully loaded. And what we're going to be doing here is simulating the customer using some of maybe his tooling. In other words, we're putting a partial capacity load on this machine. And what will happen when the system pressure in the tank drops, the engine idle RPM will raise and the inlet will start to open. The machine will be running at partial capacity. Here we are in the modulated state. With the ball valve only open partially, this is simulating again a partial load on the compressor. This is going to put us somewhere between minimum and maximum RPM and the inlet somewhere between fully open and fully closed. You just have to remember that modulation resides in between the full unload setting and the full load setting. Here we're going to demonstrate the transition between modulation to loaded. What we're simulating here is the customer's demand meeting the full capacity capabilities of the compressor. The important point here is the combined total of capacity requirements of all the operated equipment does not exceed the compressor's total capacity rating. Simulated here is the loaded state. The high demand on the compressor has caused the inlet to open all the way and the engine to run at max RPM. As long as the demand does not exceed the compressor's rated capacity, then a rated pressure should be maintained. The following symptoms can occur when the demand on the compressor exceeds its maximum capacity rating. 1. Low compressor pressure. 2. Excessive amounts of oil in the discharge air. 3. Compressor running at elevated temperatures. All three of these symptoms are very common out in the field when an operator is running more equipment or his capacity demand is higher than what the machine's rated for. What we'll demonstrate now is the proper shutdown procedure for a compressor. The first step applies to dual pressure machines only. Switch the high-low switch to low. Once you've done that, close the discharge valve. Never shut a compressor down with that valve open. The next step is optional, but recommended. Take the start-run switch or valve and turn it to the start position. By transitioning the start-run valve from the run position to the start position, it puts the compressor in a forced unloaded state. It's recommended that you leave it like this for a couple minutes to help cool off the engine turbo. Once you have given the turbocharger a significant time to cool off, simply turn the ignition switch to the off position. At this point, the engine will shut down and the panel will power off.